Now we're going to move into talking about cyclic ethers. So it's still the ether functional group where you have an oxygen with 2 carbons attached, but the ether is part of a ring system. And because ethers are so stable in general, they actually make really good reaction solvents, because you don't want a solvent to be reactive, you want a solvent to be inert, but the electronegative oxygen gives these ether solvents a dipole, and that dipole helps in solubility. So here are just 2 common cyclic ether solvents. This first one is a diether. This one is called 1,4-dioxane. The second one is called tetrahydrofuran. Or THF. That's a really common reaction solvent. Now, as we go from these 6-membered or 5-membered rings down to more strained rings, like a 3-membered ring, we still have this ether functional group, but this one is much more strained. This one is called an epoxide. So when you have a 3-membered ring containing an oxygen, that's called an epoxide. Because of the ring strain, it is more reactive than regular ethers. So in this ring, the bond angles here are about 60 degrees. And remember that ideal bond angles are 109.5 degrees for sp3 hybridized carbons. We're not going to go deep into naming epoxides. In fact, I'm not even going to ask you to name any epoxides, but just to give you an idea of how you would name an epoxy-containing compound. So here's one right here. We have our parent chain, which has 5 carbons. The substituents, we have a 3-bromo. And this epoxide, because it actually spans 2 atoms, this is a 1,2 epoxy group. So the IUPAC name for this would be 3-bromo, 1,2 epoxy, pentane.